So my talk this morning is on the application of Python on Google App Engine for transportation partnership. A bit of a disclaimer, I don't profess to be an expert in Python or App Engine. I learned it 1.5 years ago, and a project came up while I was at Michigan, specifically Ann Arbor, to work with Domino's Pizza. Domino's Pizza is based out of Ann Arbor, to look at utilizing their fleet better. So let me go on to the first, the agenda first, before the challenge. So this is what I will cover in the next 25 minutes or so. Okay, what is the problem that was given to me? Okay, and the approach that I use, which are the Python bits, which are the HTML bits, and which are the App Engine parts. I will focus a bit more on the Python bits here, and how I have adapted it for different users, be it for pictures, be it for doing similar websites but taking in different, slightly different inputs. Okay, and future plans. There are quite a lot of interest in this because I've posted it up on my blog as well. So, and quite a lot of interesting feedback that I'm getting from companies. A bit more about myself. I'm an industrial engineer by training, not a computer science or programmer. So to me, when I look at programming, it's mainly to support processes and how productivity can be improved. So an application of how I looked at this is illustrated in my project that I will elaborate on in just a bit. So as I've mentioned, this company is Domino's Pizza. It is the world's largest delivery company. They have quite a few underutilized trucks in certain regions. So the challenge is, what is near their route, the delivery route, I mean, and both along the way on the route as well as their delivery points. So why do they want to do that? They want to do that because they want to sum up all the possible partners along the route and at their delivery points, so that they can find out what possible partners can they approach, to co-share the truck, so that they can better maximize the use of their truck space and save costs for their partners. Okay, so I've broken up the challenge into 3 parts. Some of it are information given by the company. For example, on which region, which route is underutilized, is given by the company. What's near their route and delivery points. I use Google APIs to retrieve food companies within 1 mile, because Domino's Pizza, after all, is a food company. Their trucks, some parts of the truck can deliver chilled products. Some parts are frozen products. So the products has to be complementary. And in Google Map APIs, you will know for every turn, and the assumption here is that for every turn, I'm going to capture the latitude and longitude, and do a scan around that 1 mile radius, okay, to pick up companies. And after that, I sum up all the companies along that route. If it's many of the states, like if there are many Wendy's, if there are many McDonald's, many KFC, it's good. Then we can check what is the distance that these companies are currently taking when they go from one outlet to another. Compare what the KFC and McDonald's will need to travel with the additional distance that Domino's Pizza will need to travel if it goes slightly out of its way from its current route. Okay, I have an illustration of this later on. Okay, and from the fuel costs, you can calculate the additional cost of delivery to the new food companies that partners with Domino's Pizza. Any questions?
Yeah.
Yep.
Maybe one quick question.
Yeah.
Some outlets should actually probably they are running really low on stock, so
Yep.
there is an additional priority information to delivery. No.
No. There's usually enough stock at the outlets to cater to unforeseen spike in demands. So here we are talking about regular deliveries. Yeah. Of course, one of the questions that came out after this project is how can we streamline the delivery routes such that you maximize the truck and you minimize the inventory holding, or maximize the space that is at the outlet. Yeah, so that is another lead-on opportunity using this app. Yeah, but yes, these are the questions that we can solve starting with this app. Okay, so any more questions? Okay, we can make it really informal so that you can ask questions as and when you like. Okay, so this is the final solution. Okay, let me jump the gun a bit so that we all know what is the outcome that we are getting before I go into how the outcome is derived. So at the end, Google Map APIs, for those that will have used Google Maps before, on your browser, you will know that you can find distances. So in Google Maps API, you can find the current route distance. You can quite easily do so because you have that latitude and longitude of your delivery routes. Okay. So this you can find. Food companies' current route distance. This is a bit more involved because you need to find out along the delivery route of Domino's Pizza what are the food companies, and you have to select a certain food company, and the selected food company will be given a route based on where they are on the map. Okay, and based on the route, you can retrieve the route distance using Google Maps API. You have a synergized route distance here. The synergized route distance uses an algorithm called the space filling curve algorithm that routes all the location to give a smallest distance travel. Okay. And based on the synergized route distance, the current route distance by food companies and the current underutilized route distance, we can check whether it's better for Domino's Pizza, the underutilized route distance to add, say 80 miles here, between 390 to 740, 80 miles here, to deliver for this food company, or for this food company to deliver for Domino's Pizza instead. So I just use this minus this and compare it with this minus this. So 80 is definitely much lower. This means that Domino's Pizza can deliver for the possible partner company by adding 80 miles into their route, compared to if the partner company has to deliver for Domino's Pizza, they have to travel a longer distance. Okay, so all in all, okay, there's a savings. So this savings of 264 miles is the sum of this distance and this distance. Okay, this divided by this plus this. Okay. So here you have the map also retrieved from Google Maps API. Okay, we are given the distribution center for Domino's Pizza. We are given the outlets. Okay, I think this is in the state of Washington. Okay, and the outlets for the food companies are found, okay, along the way. Okay. questions? Yeah, clear enough. So where do the Python bits come in? And what is HTML? And what do I use Google App Engine for? So Google App Engine is essentially used for the whole framework of processing the information. I'm using the data store in App Engine as well. I pick up inputs using HTML, and I generate the outputs using HTML as well. So this is how my Python is used, okay, in the application, in terms of getting the delivery addresses from a web page, convert the addresses to a map, Google Map Web Services API format, retrieve the information from using web services, make sense of the Google Maps data, okay, and display it on a web page. Okay, in different ways. It could be summing up the distances, it could be converting the latitude and longitude into addresses, so on and so forth. Yep.
Do you think there's a Python program on the mobile phone to run this one?
No, it's essentially a web page.
Oh, right.
It's essentially a web page, so you have to use your browser if you're using the mobile phone. Yeah, yeah. So this picture is it's just to show that a browser is used, not necessarily a mobile phone. It could be a office laptop or desktop. Okay, so in terms of entering delivery addresses, so this is the website. If you have a laptop on, you can go in and play with it a bit. So this is what you see on the browser. So it's just some simple text and a text box that you can submit the query to. And this is my code. So I must apologize that some of the names, okay, that I have here, like guess, is not very intuitive because I just pick it up from examples, and I know what it means, so I just keep using it. So I have a form string, okay, and then in Google App Engine, in that framework, you have to display the web page, use get self, okay, and then you just put it in this fashion, and then you call the form string that you have on top. Okay. So pretty simple. I'm sure you'll be able to do the same. So convert delivery addresses to Google Maps API format. So first, let me direct your attention to the Google Maps API format. So this is the format that we need to send via the browser to Google. The only change is in this part, okay, and this requires the addresses in string, and for all the spaces to be given a plus. So then working backwards, okay, you see that the spaces will be replaced with a plus. Okay, and I join some of the spaces in the front and the end. Okay, and there could be multiple addresses. Okay, like in the earlier browser screen that you see, there are multiple addresses. So I also remove some of the enter, /n and things like that. Okay, behind. Okay, so it's a simple code to get the addresses. Okay, split it up. Okay, check for the length, check for how many addresses there are. Okay, and for each addresses, put it in a way that Google will return you based on their API format. Okay, so some of these terms again, it's not very intuitive. I just code it in my own way. But it's just about turning whatever guest text that I have into the web services format. Okay, so after I passed it to Google, this is what I get returned from Google. So I have the addresses, names, and distances. So what I did is, from the addresses, okay, I try and find out what is the latitude and longitude associated with the addresses. So I start with a latitude, and I find until I get a backslash latitude here. Okay, and I copy the string, the latitude numbers here as a string, and I append it. Similarly for longitude, okay, I do the same. Okay, and at the end I put it together. Why so? Because I have to use this latitude and longitude and pass it to another API. Okay, so I mentioned a curve, space filling curve algorithm, so that I can get the least distance traveled for all your points. Okay, so this is a simple space filling curve algorithm implementation. Okay, I think it's quite intuitive. X is, is horizontal coordinate. Y is the vertical coordinate. Okay, and then after that, I also sum the distances along the route that I picked from Google Maps API as well. Okay. Displaying data on the web page. Okay, so this is what it comes to at the end. I get the distances. Okay, I get the synergized route distance from space filling curve algorithm. Okay, I'm able to calculate the space savings and use Google Maps API to generate a display, okay, for validation.
Before you get the distance, you need to know the position of the truck.
The truck. Oh, I get the position of the. See, there's a. In terms of position, I first get the delivery addresses of the truck.
The truck is keep moving.
Oh no, the route is constant. We are looking for partners along the route, delivery route. We're not looking for partners when the truck is moving. The truck always follows the same route.
Oh, so following the same.
Yeah, and in Singapore too, when we met with companies, most truck they cover zones. Some trucks they have a fixed route because of the outlets that they serve. For other trucks, they are a bit more dynamic in terms of scheduling. They cover zones. North zone. That is my route. That is my area. And based on the deliveries I have my day. I go to that few customers. Yeah. Yep, so this is what you get. And with the same Python code, I can change the text field to take in latitude and longitude. I can take in addresses. Okay, and with the same coordinate, I can call the map to give me a display centering on a point. Okay, display a few points together, different colors, different size of markers. Okay, or I could display the synergized routes. Okay, you may not see very clearly here, but these are markers. Okay, the synergized routes follow a B, C, D format. So future plans. Okay, so one of the interesting things that we are doing is we can quite easily show the route for companies here. Right, the companies can just give us data on, for the past month, how their drivers are going to different places. So we just superimpose them every day, by week or by month, to look at opportunities for rerouting, so that two drivers will travel a shorter distance together compared to what they are doing before. Okay, pickup route and scheduling review. This is another opportunity that we're working with companies. Some of them have legacy routing and scheduling capabilities. So when the business is growing, they also take this route. When the business is down, they want to reduce the route, but they don't know how to do it. So this is another opportunity that we have with the application. Transportation partnership is what I talked about in this earlier. Okay, new business opportunities, in the sense that you already have a truck going to this area, you want to deliver for more customers, and by using this application, you already know how much distance the customers need to travel. Okay? And because you're already going there anyway, you definitely can save them costs. So that gives you a foot to the door for discussion. Delivery point analytics. So what is interesting with Domino's Pizza is that they want to overlay demographic information along for their outlets. Oops. So they can compare whether the outlets are doing well compared to their competitors. Okay, so there are a lot of public information from data.gov in the US. So that's one of the things that they're very interested to do. Okay, dynamic routing and pickups. So this is an opportunity to use the web application as and when you have urgent orders, last minute pickups. So to your point, the exact location of the truck can be shown live if you refresh the map and if you collect the GPS location on a mobile phone, for example. So if you know where the truck is, if you have a last minute pickup, with the map view, okay, you can assign the last minute pickup to the right driver, okay, instead of having to call and guess where he is at any point in time. Okay. Track and trace is another opportunity. Their customers wants to know when the truck will actually arrive. They also want to track, now with all these food scares and health issues, they also want to know which truck is bringing what kind of products and where the product comes from. Okay, so having that the database to track and trace your deliveries is very useful. Okay, and with this, I've come to the end of my presentation. Okay, this is my blog with more information. In fact, I just did another simple track and trace application for a company. Okay, so any questions? Yep.
One of your snippets of code lets me think that you may have written your own XML parser. Have you?
XML parser.
You are writing something like
So we are saying for this,
yeah.
for this, right?
Do you have a lot of that?
Yeah. So I use Google Maps API, right? They have a distance API. I think they have a map display API and a number of APIs. I'm not sure what you mean by
I mean,
parser.
I think you may want to talk to the web guys in some of the other talks because they may have libraries which could help you.
Okay.
Rather than have to write.
Oh, write this, is it?
Yeah.
Yeah. Okay. 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 Thank you. Thank you.
No problem.
Yeah.
Something called libxml2.
Because there is
Okay.
a joke that says that Zalgo will come if you don't do that, so you have to beware.
Okay. Okay. Thank you. Thank you. Yeah, that's why I'm here for, to learn from you and what other ways I can do things more effectively. Yeah. Because most of the time I do lean process projects with companies, so this is like a hobby, thing that whenever I get the opportunity, I will code. Any more questions?
So what happens if the driver mistypes and puts multiple, a little bit related to this, so when you replace space by a plus to reinsert into Google search query,
Yep.
so you just do a simple string replace,
Yep.
space by plus.
Yep. Yep.
What if your input contains multiple spaces?
I believe that there could be errors in addresses, and Google will still return you the correct information. I've tried it, but I'm not sure how much error it can take, before an error comes out. Yeah.
Yeah, I think you may want to have a look at the compiled regular expression to replace this
Okay.
multiple spaces by another character.
Okay. 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 Thank you. Any more?
Don't choose the regex for XML parsing. Never.
Oh, because I've learned about the regex, but not others.
It can't do it. It's not the tool for XML parsing. It's the tool for the replacement.
Okay. Okay. Thank you. So if not, thank you for your time. Okay. Yeah. Thank you.